Okay, so in several of your homework problems, just leave it in. They know me. I've gone crazy. Uh, it says evaluate all 6 trigonometric functions at some point. And the first one is the point 3, 4. Okay, so I'm going to do this 1, 2, 3, and this 1, 2, 3, 4. Here's 3, 4. This is the point 3, 4. I'm going to leave a little room there because I'm going to need it. What do they mean by that? Well, we're drawing this up here. We have this right triangle right here. This is some angle alpha. This is 4 high. This is 3 across. The radius here of this circle, which I'm not really going to draw in, but if I wanted to, might look something like that. The radius is going to be this squared plus this squared square root. Remember, r squared equals x squared plus y squared. That means that r, in this case, is going to be equal to 3 squared plus 4 squared square root. This is 9 plus 16 is 25. Square root of 25 is 5. And this is here. To tell you the truth, you're all done now, as long as you know the definitions. What's all 6 trigonometric functions for this angle alpha? This is cosine alpha, sine alpha, tangent alpha, secant alpha, cosecant alpha, and cotangent alpha. And of course you have to know that cosine is x divided by r, so cosine alpha is 3 divided by 5. Similarly, you need to know that sine is this divided by this, and this is real early. You got to know this by now. This is 4 divided by 5, and the tangent is just y divided by x. This is 4/3. And now it's the easiest thing in the world. Secant alpha is this upside down. Just flip it over. This is 5/3. Cosecant alpha is sine flipped over. This is just 5/4. Cotangent alpha is just tangent flipped over. This is 4/5. Oops, that's not flipped over. It is 3/4. That's it. That's all there is to this. I'm going to do another one of these to make sure that you're feeling more comfortable with this. So the next problem says, find all 6 trigonometric functions at the point, where did it go, -5 and 12. Okay, so now I'm going to have to do my best to draw here. -5, 1, 2, 3, 4, 5, -12, positive 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is about as good as I can draw this. So here it is. Oh, no, that isn't going to work. Let's try it like this. Oh, jeez. Okay, so this is just going to be the world's ugliest triangle. Now remember, this angle that is being represented by this picture, this is alpha right here. Although we're using this triangle to calculate things. So this is -5, this is 12. This radius right here by Pythagoras is -5 squared plus 12 squared square root. This is r. This is 25 and 144. That ought to be 169. So this is 13. Square root of 169 is 13. Do I really believe that? So you got to be careful when you're lecturing, because if you say the wrong thing, it looks really bad, and you can confuse the students. I think this is right, but it's been a long day, and I encourage you to also do this. If you're not sure, you're tired or whatever, check these numbers. So this is 25 plus 144, 169, square root is in fact 13. Now I have everything that I need to know practically, and maybe I'll put these up. The cosine of alpha is x over r. The sine of alpha is y over r. The tangent alpha is y over x. The secant of alpha is this upside down, which is r over x. And the cosecant of alpha is this upside down, which is r over y. And the tangent of alpha, or the cotangent of alpha, is tangent upside down. This is x over y. So these are a piece of cake. Cosine of this angle is x divided by r. What's x? This is x. It's negative 5 divided by 13. And let me see. I guess I'll write these up next to it. I was looking for a nice feisty red, but I guess we'll go green. So this is negative 5 divided by 13. Sine of alpha is y divided by r. This is sine is the y part is here is 12/13. And the tangent is going to be y divided by x, which is equal to 12 divided by negative 5. Technically, this is fine. Leaving a negative 5 on the bottom is no big deal. We tend to like putting that on top, or at least in the middle. I guess I wouldn't be evil in grading if you left a negative 5 on the bottom. Probably some professors wouldn't be that great with it. This is still 12. I just wanted to make it better looking too. Now that these are done because it's just these upside down. This is negative 13/5. This is 13 over 12, and this is minus 5/12. That's all there is to it. Piece of cake. I mean, there's some memorization in what the definitions are, but that's about it. The next thing we're going to do is try and evaluate all 6 of these trigonometric functions at 4 pi over 3 radians. And for that, they gave you a little thing to look at. They said, don't use your calculator, right? Ultimately, when you're taking a test, when you're building an airplane, you will use your calculator, or we'll be unhappy when we fall out of the sky. For this, though, this is what they want you to be able to do. So first, we're going to draw our unit circle. And there's a handsome unit circle. And I want to remember a couple things. So here's the x-axis. Here is the y-axis. 4 pi over 3 radians. Where is that? Well, so this is pi. So let's go by thirds. Remember that pi over 3 radians is equal to 60 degrees. So here is, and this is just approximately, so here's pi over 3. Here is 2 pi over 3. Here, and of course this isn't perfectly drawn. This is 3 pi over 3. So this pi plus pi over 3, this angle's the same as this. This is 4 pi over 3. So what we're talking about is this angle. This is the angle 4 pi over 3. However, what we're going to do is we're going to be using this triangle to figure out all of these identities. And my producers just told me that it's time to take a quick break. Right back.